that I realized how little people know about the interactions between nature and society. And that is when it became my passion to share the word with many people, as many as I can. So I've spent the last 4 years speaking, including the COVID year, which introduced us all to virtual settings, which is great because this is the easiest commute I ever had. And I'm up here in Bergen County. I live in Paramus right now. I grew up here. I then lived in Seattle for 20 years almost, and then I moved back. So without further ado, let me share my screen and where should it screen? Share and begin. So this is a slideshow. This show is Ellen asked me to talk about climate change, and this is my organization. If you want to Google me, pretty much I go out and I do speaking, and I also do curriculum development, also on climate issues and other environmental issues as well. I want to thank the Climate Reality Project. I've also been a trained leader there. That's Mr. Al Gore's organization who trains a cadre of people to go out and speak about climate change. And he also provides people with slides. Some of the slides you'll see here are his. Many of the slides you're going to see today are actually my own. But Climate Reality Project gave me my first voice in this matter. But today we're going to talk about climate change, facts, and solutions. And what I've done, Ellen also mentioned I've learned a new tool that's called En-ROADS, and that's a climate simulator. So I'm going to give you an abbreviated version of this presentation, and then hopefully we're going to work together and take a look at what it's going to take to actually stop global warming. But to begin, you know, this is our only home, and everything we do is from this planet, and everything we throw away actually pretty much stays here. And our society now has the tools and the power to change the surface of this planet. And of course, some of those consequences include global warming and climate change. And so that's what we're going to talk about today. We're going to talk about the causes, and really it's very simple. The cause is that we have too many greenhouse gases in the atmosphere, and the impacts, I'm going to race through quite a few of those impacts that we're seeing about global warming. And the solution, we're going to look at that in a little more depth using that En-ROADS simulator. But in theory, it's simple. We need to stop emitting greenhouse gases, and we need to remove them from the atmosphere. And we need to do that where it becomes a little more difficult is with sustainable and equitable practices as well. So that needs to be kept in mind. So, but let's begin with make sure that we all understand what is global warming. And already the planet has average global temperature has increased by 1 Celsius degree. Now a Celsius degree, as you can see at the bottom here, is a little larger than a Fahrenheit degree. So it's increased by 1 Celsius degree in 100 years, and we need to keep that increase below 1.5 to 2 Celsius degrees to avoid catastrophic changes. And we can see in this data, I'm a science teacher. I happen to love data and charts. I know not everyone does, but this really isn't as complicated as it looks. This graph shows the average normal temperatures. Now check this out, between 1951 and 1980, so the middle of the 20th century. And the white are the normal temperature days, the red are warmer than normal, and the blue are cooler than normal. And you can see it is a random, pretty much a random spread, and this is just the baseline. We're going to keep that green line there so you can see what happens as we go through the decades. So starting in 1990, this all began to shift. And you can also see on the lower right the appearance for the first time of statistically significant number of extremely hot days. You'll notice that the cooler than average days, we're getting fewer of them. And as we go into the last 20 years, you can see that those extremely hot days have become more numerous than all of the colder than average and average days put together. And these extremely hot days have increased by more than 200 times, and they're driving the extreme weather events and many of the other impacts of the climate crisis. I also want to just point out that this is our new average temperature right here. This is where it was in the 1950s, 60s, 70s, and 80s. And here's where it is today. So our average temperature, when they say it's average, it's already warmer than it was. And the extreme temperature events that used to cover less than 1% of the land now covers 22%. You'll also notice, though, that we still do have extremely cold events, just many fewer than we used to. So that's on a global basis, and you can see how the temperatures have increased over the last 70 years. And New Jersey, if we go locally, we see that New Jersey is already 3 degrees warmer, that's Fahrenheit, than it was 100 years ago. So 2012, according to the State Office of Climatology, which is through Rutgers, 2012 was actually the hottest year on record for the state of New Jersey, while 2016 and 2020 tied for the hottest year on a global basis. And this year may be ranking as the hottest for New Jersey as well this year. But technically, 2012 was the hottest year. And that just shows that global warming does not affect the whole planet in a uniform manner. And we're going to see that as we go on. So what is the science behind global warming? Well, global warming, the reality is that solar radiation in the form of light waves passes through the atmosphere, and most of that radiation is absorbed by the earth and the air and the sea and the land, and it warms it, and that's a great thing. And as the planet warms, it turns some of that energy from light into infrared radiation or heat, and some of that is re-radiated back into space. And that's a good thing. And some of that outgoing radiation is actually trapped by the atmosphere and continues to warm the planet. And that is the greenhouse effect, and that is what our atmosphere in general has allowed life as we know it to flourish on this planet. And this effect has been stable for over 10,000 years. But lately, as we are pouring more carbon dioxide and other greenhouse gases into the atmosphere and their concentrations increase, more of that outgoing infrared radiation is trapped. And so as it's trapped, the planet is becoming warmer. It's as though we're putting on a blanket made up of these greenhouse gases. And again, the planet is heating up, and we are seeing the effects of that. So while there are several greenhouse gases that create this blanket, really the one that humans have dumped into the atmosphere in exceptional amounts is carbon dioxide. And that's why you hear so much about that one in particular. And these emissions have skyrocketed. Particularly, you see in this graph, it's billions of metric tons of carbon. And here's the, on the x-axis is the time, years. And so we had very little in the atmosphere at the beginning of the Industrial Revolution. And you can see that post-World War II, it's really taken off, and the amount of carbon dioxide we are spewing into the atmosphere. And if you look closely, you can see a dip there in 2020 because of the COVID crisis, which is great. But don't be surprised, it's going to be going up, I'm sure, this year. And that's why we need to take action. And so once again, to make sure that you're aware of this, anything that comes out of a tailpipe or any pipe that we burn, every chimney, every car tailpipe, and by the way, you'll notice Teslas don't have tailpipes, nor do any other electric vehicles, which is great. Anything that comes out of a smokestack, anything we burn, including wood, even though that's not officially a fossil fuel, but combustion itself, the product, it's a simple chemistry reaction. And I used to teach chemistry, produces carbon dioxide. And anything that's a gas-powered lawn tool, anything that burns, especially coal, gas, or oil, emits greenhouse gases, primarily carbon dioxide, whether or not you can see or smell them. Many of them are odorless and invisible. So even if you don't see it, it's emitting greenhouse gas. When you're idling at a traffic light, you are emitting greenhouse gases and other pollutants. So we have entire industries in our modern society that emit greenhouse gases, either as a byproduct or a direct product of their functions. And here in the US, our top producers are air and land transportation, as well as electricity generation, primarily from either coal or fossil fuel or gas. And it's different in other countries. But one thing that I found interesting is that industrial agriculture produces a lot of greenhouse gas emissions, not only from chemicals, but also from the ruminants and their biological functions. And if we want to take a look at this again in terms of quantities and look at the numbers, according to Project Drawdown, this is where the greenhouse gases are coming from according to economic sector. So electricity generation is responsible for 25% of all the greenhouse gas emissions. Our agriculture and land use practices are almost responsible for a quarter. Industrial practices, particularly creating cement, is responsible for 21%, transportation 14%. This is on a global basis, by the way. Our buildings themselves generate 6% of the emissions, and this other is energy related emissions, and we're not going to address them right now. They're more subtle. So we've been over the problem, and we've talked about what the cause is in a very quick way. So let's talk about now, we're going to spend a few minutes on the impacts of global warming. And there are so many. It affects the entire biosphere. And I don't have time to go into all of these. I will touch on them, maybe one slide per. We're going to look at weather patterns and sea level rise. We're going to take a quick look at health issues and food generation and nutrition as well. So let's start with weather effects. And we're going to talk about temperature and precipitation and extreme events. And these things haven't been happening immediately. They've been happening over the last 100 years, and we're starting to see tipping points too. They're just becoming more exacerbated at the present day. So parts of the world are becoming drier, and we're seeing more heat waves. And these are droughts in India and the Philippines. You can see in these images here. And of course, droughts and dry, hot conditions make it ripe for forest fires, which we have seen in California and Australia, terrible fires in the last few years, which isn't helping with particulates and other pollutants and emissions. We're going to see more and more heat waves as we're having in California. As we progress throughout the century, scientists predict that heat waves will occur more often, last longer, and have higher average temperatures, a triple whammy. We're also seeing changes to the jet stream and the polar vortex. Observations are pointing to a slower down and more waves and stalled events, weather events. And we're seeing new phenomenon such as atmospheric rivers and that splitting of the polar vortex. That splitting is when we get those bitter cold days in the mid latitudes like Chicago. And it's actually above freezing at the Arctic on many of those days. But here's a satellite image of an atmospheric river. And when I lived in Seattle, we called these things pineapple expresses. This one is starting in Hawaii, and you can just see this river of clouds and precipitation. And here it's landing in California. But whether it lands in Washington, Oregon, or California, it often brings serious flooding along with it. And in general, we're seeing more and more heavy downpours. As a matter of fact, the Northeast, as I'm sure you've all noticed, we're becoming more tropical. They predicted this as early as 2010. And in the 12 years or 10 years since I've moved back, it's definitely gotten wetter and wetter. I sometimes feel like I'm back in Seattle, to be honest with you. But anyway, warmer air holds more water. Warmer oceans evaporate more water vapor. And so water vapor in the atmosphere generates bigger downpours. When it comes down, there's more of it to come down. And we've been seeing a lot of that, especially during our summer thunderstorms here. And it's not just local to New Jersey, of course, or even the Northeast. We're seeing this is the global record-breaking precipitation anomalies. That means how many records have been broken. And you can see that since 1950, the trend is obvious. We are seeing more and more record-breaking precipitation. And while I have a gazillion slides of these, I don't have time to show you them. But here's just a couple of some of the devastation that some local storms have strewn around the world. So here's Hurricane Irma in 2017. devastating St. Martin. You remember, I'm sure, Hurricane Harvey in Houston, Texas. Here's Cyclone Amphan in Calcutta, India last year, and some of the devastation in the middle of a pandemic, I might add. Here's flooding in the Yucatan Peninsula, and here's more flooding back in India. But this has happened all around the world. These are just images that I found relatively quickly. But in addition to more storms, and not only more, but stronger ones, we're also seeing, as I mentioned earlier, fewer cold days. And this is a graph of observations, real data from right here in Central Park in New York City. And you can see that these are the number of days and the number of days that were below freezing, or 32 degrees Fahrenheit. And you can see clearly that the trend is that we have fewer days per decade. This is since 1900. We now have 22 fewer days below freezing than we did in 1900. And I don't know about you guys, but I'm old enough to remember ice skating in my hometown here in Bergen County. I grew up in Tenafly, and there were several ponds that we'd go ice skating as kids. And that was a lot of fun. And I even earned a Girl Scout badge on the pond right downtown Tenafly. But now my kids, it's only been a story to them because the ponds here no longer freeze like they did when we were children. But as you're probably aware, it's not only the land that's absorbing the heat and the carbon dioxide. Most of that extra heat, most of it is being trapped in the oceans, and partly because the oceans cover over 70% of the planet. And that's having a big effect. So climate change is affecting the oceans in numerous ways. First of all, they are getting warmer. And as they get warmer, believe it or not, just like everything else, they're undergoing something called thermal expansion. Again, that's basic physics. And they are just getting larger because they're getting warmer. They're also becoming more acidic because the oceans are not only absorbing the heat itself, the energy, but they're also absorbing the carbon dioxide, which when it goes in water turns into carbonic acid like in sodas. And so the oceans are becoming more acidic. We're seeing problems with shells that aren't forming properly, and more coral reefs are bleaching due to both the temperature and the pH factor. They're becoming less salty because of the land-based snow and ice melts from Greenland and Antarctica. And sea level is rising, not only because of this increased water from the land, but also because of the thermal expansion. And this is a long-term effect that is going to be difficult to stop. And while it's affecting millions around the world, 40% of the human population lives on the coasts. And so as sea level rises more and more, this is going to affect more and more people around the world. But not only is it affecting people, of course, climate change is affecting all marine life in all parts of the world. And here we're seeing particularly high sea level rise. This is from Rutgers. This is sea level rise according to tide gauge data and satellites. And the green line you see here is New Jersey. The brown or orange is from New York City. The global sea average is in the black line here. And you can see that since 1920, which is here, sea level rise in New Jersey is already over a foot higher than it has been. That's the average along the coast. So we've already seen sea level rise of a foot, and that had some of the impact when we had those storm surges during Sandy. So sea level is rising, and it's going to continue to rise. And along with it comes these worse and worse storm surges, as we saw in Sandy. And there's also more tidal flooding, as you can see here in this picture in downtown Miami. But we have it, Staten Island sees it a lot, as well as the Rockaways in New York City. I'm not sure where they see a lot of tidal flooding here in Jersey right now, but tidal flooding is happening all over the world more frequently. This is Miami, and it's happening so frequently in Miami. There was no rain here. The water, instead of going down the storm drains, came up through the storm drains and floods the roads in Miami Beach. In some places so often that they've actually installed pumps to pump it out, and in certain parts they have raised the street level by 12 inches. to try to avoid this nuisance. But Miami is one of the richest cities of the planet. So what are they supposed to do in villages like this in Bangladesh? In 2014, because of an exceptional high tide of the Ramnabad River flooded out, it was so high that it flooded 100 villages in one weekend. Their earthen dam here, you can see, it just burst and the river flooded their village. What are these people supposed to do as their village floods? Are they supposed to raise their street levels 12 feet, 12 inches? And how many greenhouse gases do you think that any of these villages emitted compared to one evening rush hour in southern Florida? And that's how this climate change is also an ethical issue, which I don't have more time to go into today. But many of the most affected communities, or the communities that are most affected, are not responsible for emitting most of the greenhouse gases. Many of them are poor, don't have the tools to deal with the climate change, and what can they do, and what should we do? And of course, sea level rise is causing serious problems around the world. But it's not only around the world, it's right here at home. This is a small town in Louisiana in the Gulf of Mexico. It's Ile de Jean Charles, and it is one of our country's first climate refugees. In 1955, this town consisted of over 22,000 acres and has since lost about 98% of its land due to saltwater intrusion and subsidence. And the Army Corps of Engineers decided it was too costly to protect the island from sea level rise. So in 2016, the Office of Housing and Urban Development gave Louisiana a $48 million grant to move this village. And they did move it. They came up with a solution in 2018, but it had lots of problems. I don't even know if it's fully implemented now. And of course, there are indigenous peoples here that are very hesitant to move because this is their ancestral land as well. So this is right here in this country. And there are people like in the Lancet reports that predict that the world could see up to 1 billion climate migrants by the end of the century due to things like sea level rise and water scarcity issues that are all brought about by global warming and climate change. The Department of Defense recognizes it as a serious problem. And as of 2014, they issued this statement that climate change will likely lead to food and water shortages, pandemic disease, disputes over refugees and resources, and destruction by natural disasters in regions around the globe. So you can see those are many of the other impacts that can happen due to some of the physical things, but let's touch on other impacts of climate change. And I do only have a couple minutes to touch on these, but let's talk about how climate change is going to affect our food system. And I don't have a ton of time to do it, but we're going to hit a few of these right now. And right off the bat, heat itself, as the temperatures raise, alters the yields of many crops. They've seen this in lab reports, in lab experiments, rather, that the grains that we have cultivated for 10,000 years, as the average temperature goes up, the yields go down. We're also seeing that crop nutrient is also affected. The crops grow faster, but they don't metabolize as many nutrients as they did in the past. And fish too become less nutritious. According to studies, the quality of the protein decreases as the temperatures go up. We've touched on drought already, and droughts along with storms and floods, as well as fires, all destroy crops. And so we can't even feed ourselves if these things should hit your food sources. And climate change is creating a warmer and wetter environment where pests and diseases such as wheat leaf rust and soybean sudden death syndrome become more prevalent. So you can see how climate change is affecting the whole food system. And lastly, I just want to say that higher temperatures and droughts can cause toxin accumulation in plants and livestock, which threatens the health of humans and animals. And they talk about toxins like aflatoxins in corn. So our food system is affected in many ways by climate change. And we in the United States can use technology and chemicals to compensate that but not in many of the places where there's subsistence farming. And also, as you can see here, I pressed the button a little early. Uh, there are multiple impacts that the climate crisis has on health, and they're all interrelated as well. So I'm going to start with air pollution. And this is kind of a push, I'll be honest, because air pollution is not the same as greenhouse gas emissions. It's a part of greenhouse gas emissions can be considered a part of it, but really air pollution we look at as particulate matter. But the reason it's so important in this discussion is because it is intertwined with global warming and climate change, because the exact same thing that is causing global warming also causes air pollution, and that's the burning of fossil fuels, coal, oil, and gas, and even wood and other dirty fuels. And here again, we're talking about particulate emissions, and the most injurious have been found to be those with diameters that are very small, 2.5 microns or less. So we call them PM 2.5. And these particles can get into our lungs, and they really mess up our respiratory systems. And according to the WHO, worldwide air pollution kills about 9 million people every year. That's the Lancet Commission, and the WHO has said actually about 11 million. So there's a lot of people that are affected by it. I know since I've moved back to New Jersey, I seem to have developed asthma, and I'm not sure how that happened, except for the air conditions here. And here's a picture. This isn't so long ago, 2010. This is a smoggy day right here in LA. And we've seen what the air in New Delhi and Beijing looks like as well. And so while we haven't had days like this in New York too badly, this type of air pollution still exists all over the country and all over the world, and it is directly from burning fossil fuels. Here in New Jersey, we have exceptionally high ozone levels, which is also from fossil fuels, and primarily it's from the transportation and the highways that are run and ports in this state. But one of the biggest killers in global warming actually is heat stress. And more people are dying due to the heat events in this country than to any other natural disaster. And the old and the young and the ill are the most vulnerable to heat events. And of course, there's also more allergens. And that's because plants love, as you guys are master gardeners, you must know that the plants take in carbon dioxide and sunlight. Well, they love that there's more carbon dioxide out there, and they love that it's warmer longer. So the plants are blossoming earlier and they're producing more pollen. There's more pollen in the atmosphere than there ever was in the 70s, let's say, and that's expected to grow significantly. Climate change is also changing the world to make it a better place for infectious diseases of different kinds. Insect-borne diseases like those that are from mosquitoes, not only mosquitoes, but also ticks and other insects, these diseases are becoming more prevalent, partly because their ranges are expanding and partly because their viruses in them are incubating faster, and that gives us more infectious bites because there are also more active days because there's less freezing days. So mosquitoes, ticks, and other insects, these types of diseases are growing. We're also seeing waterborne infections, particularly when floodwaters mix with raw sewage. And cholera outbreaks and epidemics are prevalent in certain parts of the world now that have poor sanitation. And there happen to be billions of people on the planet that do not have appropriate sanitation, even toilets or latrines right now. And the last impact I want to mention today, although as you can see there are many, is that we're risking losing up to 50% of all land-based species and many water-based species, marine-based species, by the end of this century. The scientists have already declared this is the beginning of the sixth great extinction, with the last one being the dinosaurs. And the deal is that the environment is changing faster than primarily the larger animals, more evolved animals can evolve along with it. And along with habitat loss and other anthropogenic causes, is adding up to a possible loss of many, many species by the end of the century. So we've raced through some of the impacts of global warming and the way it's affecting all our life and our biosphere. And so what's the solutions of that? And the bottom line is that we have to reduce our greenhouse gas emissions by 50% in the next 10 years, according to the scientific predictions. And there are more than 35 different climate simulators that are running these different parameters and models. And we have to go to net zero by 2050 in order to keep global warming below 1.5 degrees Celsius. And we're going to look at what's going to take to get that in just a couple minutes. But I may have depressed you a little bit now, and I want to give you a sense of hope because we can do this. We have, as a society, changed many times just since the Industrial Revolution. And I want to give you a very quick rundown of that. So it was when we harnessed fossil fuels that gave us the power to create our modern society. But we also had this unintended consequence that we didn't realize until recently. And since the modern era began, we have had an industrial revolution, though, where we changed and created mass production. We've had a transportation revolution. We no longer use a horse and buggy, but now we can travel by car, by plane. And look, we're going back to fossil fuel-less travel in terms of this is an electric vehicle right now. This is a Nissan Leaf. We've seen communications revolutions where instead of writing letters that take days or weeks, we can talk to anybody around the planet in a matter of moments. We've certainly seen a healthcare revolution with the development of these new vaccines of COVID, and more people are staying alive than ever before. And of course, we're in the middle of an information revolution where all you got to do is Google it and you can find out information about anything, which is amazing. And so what we're on the cusp of now and what we need, and I don't have time to go into today, but we need to have a sustainability revolution. And that is what academicians are speaking about and others as well. And that is where we have to change and create systems and practices for our society that can be sustained for many generations to come, not only for humans, but also for the other organisms that we share this planet with. And so we have to take remember this graph I showed you before, we have to take all these sectors and we have to make them 100% renewable energy, and they have to stop emitting greenhouse gases. We need to bring all these numbers down to zero. And again, the good news is we have some roadmaps to reach our goal. We just have to adapt them and adopt them as well. And the United Nations has adopted the most comprehensive framework for going forwards in this century with sustainable and equitable practices. And it's very lofty. It's called their Sustainable Development Goals. They have 17 of them that they're hoping to meet by 2030, although COVID really put a setback in them. We have today been only talking about number 13, which is climate action. If you'd like, I'd be glad I have another presentation where I describe these, but I don't have time to go into it today. And here's from Stanford. They have a roadmap that they can get 100% renewable energy in 139 questions. They can create jobs, save money. That's another roadmap on how to get there. Then you may have heard of Project Drawdown. They've become very famous, a team of more than 200 scholars, scientists, and policymakers. If you Google Project Drawdown, you can get to their website and get their book and their newest book for free. And what they've done is they have come up and studied with 80 of the most effective solutions to stop global warming, technologies that exist today that we can implement right now and bring to scale, some of which are to scale. And these are the icons for each of them. And you can go on their website and learn more about these as well. But I also want to point out that this really can work and we can make big changes. This is what happened during the COVID shutdown. And during the shutdown, we stopped burning fossil fuels because we shut down most industries and most transportation. And in just a few short weeks last year, we saw the air pollution, particulate matter, PM 2.5, drop significantly. In LA, it dropped 31%. Right here at home, 25%. Sao Paulo, 32%. In virtually every city around the world, it went down. In a couple places, it went up, and that, including Rome and Beijing, and they think that's because of changes in the wind patterns because we shut down um, the the wind patterns that our economies generate, believe it or not, in our cities and all. And so in just a few weeks, we saw air pollution in these major cities drop significantly. I'm sure you saw that in the news. And so think if we act together consciously, and we don't want to stop by shutting down our economies, but if we transform our economies to stop relying on fossil fuels, then we can create this same type of clean air that's healthier for us as well as other uh, organisms. And so quickly, I would like to, if we have time, Ellen, I'll let you tell me whether or not we can do this. I'd love to show you En-ROADS. It's a climate simulator that's developed by Climate Interactive and Tana Systems and MIT Sloan School. And it developed to understand the climate impacts of our energy supply choices, our transportation policies, as well as our land use policies. And it allows you to look at this. It's interactive. We're going to do it together, I hope, today. And then maybe you can experiment with that more. But before we do it, I was wondering if we have any questions. I'm going to stop right now. I wasn't able to see the chat. Okay. Do we have any questions that you guys want to ask right now before I move on? I know that was a lot of information.
Yeah, I have a question or a comment. Two things that I've read about. One is the X Prize for CO2 sequestration and in concrete. Apparently that was the winning. Was that a winning? And the other one was I just read not too long ago about feeding seaweed to cows reduces their
methane emissions.
Methane by 85%. I thought that was.
So those are both two valid things that are happening there. Great points. Those are methods that we're adopting to try to fight global warming, but we have to do a lot more than just feed seaweed to cows.
Yeah.
And unfortunately, concrete emits carbon dioxide as it sets. So while you might want to sequester some, we actually have to figure out other ways to generate these building materials. And they're talking about that and they're looking into it.
Right, thank you.
Ellen, is it all right? Can I start En-ROADS for just a couple minutes even?
Definitely. We usually go for about an hour. So you probably have about a good 10, 15 minutes left.
Great. So I'm just going to share, and I'm hoping you guys will unmute yourselves and actually do this interactively with me, because that's what this is meant to be. I am going to take this 1 second. And so you can see in the chat, if you feel more comfortable posting in the chat, maybe Ellen, you would read them out to me. But,
okay.
So you can do it that way. This is En-ROADS, and it's a screenshot, and I just gave you the link to this exact screen. And what you see here is 2 graphs, and this is global sources of primary energy. This is the standard screen, and greenhouse gas net emissions. According to most scientists and scenarios, they believe that the temperature increase, if we do nothing and continue as we have done for the last 150 years, that by the end of 2100, we will have a rise average temperature of 6.5 Fahrenheit degrees and 3.5 Celsius degrees. And that is going to have some major catastrophic weather changes and other environmental changes along with it. So according to that Paris Accord, the goal is to keep it down to 1.5 to 2 degrees Celsius. And the question is, what is it going to take for us as a global, this is a global simulator, but it should give you an idea of what we can do globally, and then how do we make that happen locally, that we can keep that temperature down. And so this allows us to move sliders, which simulate actions in energy supply, transportation, buildings and industry, growth in terms of population or economic, land and industry emissions, and then carbon removal. So, for example, that gentleman mentioned, I'll start us off. He mentioned that they were thinking of feeding seaweed, and they have found that it works to cows, certain type of seaweed. I think it's pink, helps reduce their methane emissions. And what I'm going to do is I can go into here, and this is such a robust piece of software. I love it. You can learn so much right here. If you click, let me show that again. If you click on these vertical ellipses, you get these other screens. And if I click on I, it will tell me more information about this. And I can find different graphs here as well. And actually, I want to go to methane emissions, which is CH4. And here, if we use detailed settings, if we want to have cows emit less methane, we can take this. This is for both cows and agricultural waste. If we try to reduce a lot of methane from that, you can see that we only reduce our global temperature by 0.2 degrees. So that does not change our energy uses or anything. So that's one thing we could do to combat global warming. Does anyone have a suggestion of what they'd like to see us try?
Well, I'd like the coal industry to decrease.
Yes. Would you like me? How about we stop using coal?
That's a good
Wouldn't
idea.
it be nice if we globally stopped using coal? So this allows us to tax it. And rather than tax it, once again, I'm going to go in here and I'm just going to say, stop using coal, reduction in coal utilization. And I'm going to bring that to 100% and look at what happened to our greenhouse gas emissions and our coal use. It went away. And I'm going to replay that quickly so we can see it. But as we go down, I want you to note that on the brown is coal, the red is oil, the blue is gas, green is renewables, pink is bioenergy, the light blue is nuclear, and orange is net zero. That's a new technology. We're accepting the fact that there might be a new technology that doesn't burn carbon dioxide. But as I'm going to replay it one more time, as coal goes away, our use in oil and gas actually increases a little bit. So as well as renewables. But you can see that we were actually able to bring down our global temperature a bit, but we're still not there. And by the way, this means that the whole world has given up coal, which would be very nice, but I don't know that that's going to happen. Hopefully that's going to happen soon. But in many places, including Africa, where people still do not even have access to electricity like we do, the cheapest and easiest and fastest way that they're finding at the moment is still they're building coal-fired plants. So, which is sad, but these people aren't even on the grid. So what do they do?
I have another question.
Yeah.
So I just read an article about how they're cutting down trees in the Carolinas to produce pelletized fuel to burn in Europe, and they're claiming it's zero carbon emission. So I'm just wondering if you read about that, or how that could possibly be zero carbon emission, or carbon neutral, I think actually called.
I'm not cutting down trees to burn.
Well, they cut the trees down and then they grind them up and make pellets, ship it to Europe, and they use that as fuel. That's apparently part of Europe's plan to reduce emissions. They're just shifting it apparently to the United States.
I think that's a little bit of greenwashing, but there is this thing about using bioenergy, and that does fall into that category. And here we can bring that up. Let's say we're going to do it. You don't see a big, it doesn't have a big increase here on this, which is a good thing. But bioenergy actually creates a lot of air pollution. So it's not the greatest thing, but the deal is, the reason that bioenergy is different than fossil fuel energy, because fossil fuel is getting the carbon from in the ground and in the crust, and bioenergy is already taking, by using living materials and things that were plants and were living, that's carbon that's already on the surface of the planet. So it's taking things that are on the surface then at least, But the problem is it's taking it from the surface and in living things, and when you burn it, it's putting it in the atmosphere, which is what we don't want. But this reminded me that I wanted to point out something, that there's also not only that if we, I mentioned it with air pollution, as we try to mitigate global warming, we can have multi-beneficial effects. And I wanted to bring up that air pollution. Let me find it here. There's over 95 different graphs in this different, let's go to the simple one. Sorry. So here's air pollution from energy. And you can see actually that if we reduce the coal, it's the coal that actually we can reduce that air pollution significantly while we also fight global warming, which is a great co-benefit of this particular action. Bioenergy does not produce such a same effect. As a matter of fact, you saw that the bioenergy actually increased the temperature by a point or so. Anybody else have something else they want to see? How about we go to electric cars? My husband just bought a Bolt. Great deal on 2021 Bolts. And he bought one, and if we were able to electrify the entire vehicle fleet around the world, you'll see that we can bring down that temperature by even a few more degrees, and we can also help protect, reduce air pollution as well.
Susan, I do have a question that I'm a little confused by. And the wheel chart that you had up prior to this slide presentation, the wheel chart that showed the contributor portions of
Right.
these for greenhouse gases, I noticed that electricity showed at 25%, the largest contributor within that chart. How does
Right.
that relate here? I don't see electricity. I mean, if
That-
electricity is 25% of our pie chart, I don't understand how it's a better source to help our environment and greenhouse gases.
Okay, so electricity generation is generally, in this particular application, you think of it as our energy supply. These were, just so you know, these are economists, MIT Sloan, that's the business school of MIT. And so these are economists that made this up, and those are scientists that made that sector. 25% of all the greenhouse gas emissions are because of electricity generation and energy use. In this scenario, we are looking at energy for electricity, and we're looking at energy for transportation, and we're looking at energy for industries. So we're looking at a broader sense of energy. But how this relates to that is that most of the coal generates electricity. And we also, where in New Jersey, as a matter of fact, do we generate our electricity is coal, but that has been going down. They've closed several plants now. But here where I live, we get our power from natural gas. So you can see on this graph that natural gas is a large sector of our sources of energy. And it's also a polluting method, and generates greenhouse gas emissions. In addition, South Jersey in particular gets its energy from nuclear power. And nuclear happens to not be, in terms of greenhouse gases and global warming, nuclear is a good option. I'm not saying it's a good option for other reasons, but in terms of not emitting greenhouse gases. So does that kind of help? So what I'm saying is, in this graph, that we'd have to reduce our coal use, which is what we did, and we'd have to reduce our natural gas use.
To generate the electricity. But I was still confused by that chart, but you're saying two different people produced the chart. That previous chart saying 25% of electricity use is what's contributing to our greenhouse gases.
No, other way around. 25% of all our greenhouse gases are created by electricity generation.
Generation, not electricity use. Okay.
Right. It's the generation that does it. It's not the use itself. So here, this is the amount that we use of electricity total. If you cut to this 9, it's 900 and some odd exajoules per year by 21,000. Actually, I'd have to figure it out total. So currently we're about at 600 exajoules That's where we are right now as a world. That's how much power we get in energy. 25% of all the global emissions are due to producing energy. Electricity are due to producing electricity. 25% of all the global emissions of greenhouse gases are from producing energy. So let's pretend, let's say we can stop all the emissions from electricity generation, we would automatically reduce that number that you see there by 25%. If we could magically do that. And that's the idea that they want us to see it here. What if we got all our power from renewables? Let's take a look at what that would happen. You see how we got more of our energy from renewables, solar and wind and geothermal in particular. And then our energy use went up. You know, I was taught, turn off the lights, save energy, save power. If everyone was able, if we made solar panels that were 80% efficient or better, then we would all be getting free energy from the sun. And then you wouldn't have to be energy efficient. You could use as much as you want because it would all be free, and it is renewable, and it's going to last us billions of years, which I think is forever. So we wouldn't have to save energy if we got it all from renewables, if that makes any sense. Does that help?
Yes, thank you.
And then the other 14%, we said that transportation was that energy that we use in transportation, that's responsible for another 14% of all the global emissions. And so by making our transportation systems more efficient, we're using less energy. Did you see how that went down there? The amount of energy that we're using actually shrinks because I've made my transportation sector more efficient. And that includes, if you read the details here, that would include having more people walking and more people riding bicycles and more people taking mass transit, which hopefully runs on electricity. Quebec and Beijing, both cities have now electric fleets of electric buses that they use. So their mass transportation is getting cleaner and cleaner instead of those disgustingly idling buses that you used to see and still do. And then again, you think about the other co-benefits, school buses in front of schools, idling all afternoon and all morning. Those are actual health hazards for the students and the parents and the teachers and anybody there. And so if we could take our school buses, and while this is a global scenario, it should give us ideas if we could just transform our school buses one school at a time. Do you know how much cleaner that air is going to be right outside the front door of your daughter or son's school? And but there's another thing that we need to think about too when we do this, and that is, I just wanted to point out the costs. As we do things like stop using coal, the costs of our energy are going to go up. And for us people, middle-class people, many of us in New Jersey, we'll hopefully be able to cope with it. But how do we deal with that? And does it have to fall on the consumer? Perhaps the governments are going to take that into account. But this has to be an equity concern, because who is it going to fall on? Who's going to be hit hardest? Will poor people still be able to afford to heat their homes and light their homes? And I certainly hope so. So we have to take these impacts and into consideration as well. And that's what this is such an awesome tool for, is it shows us that how these things impact one another. And by the way, doing all this, I'm still at 2.4 degrees Celsius. I haven't even hit the goal that I'm aiming for. And I've already electrified all the cars and the buses, and we've electrified almost everything. If you read the details here, we can't actually, right now, we don't have the technology to electrify ocean-going ships and airplanes, although they are definitely working on hybrids in airplanes as well. So does anyone else want to throw something else or have another question?
We had a couple of more comments in the chat. Somebody suggested a reduction of air travel, and a couple of people were concerned about deforestation.
Excellent. Well, this model doesn't actually demonstrate a reduction in air travel. The most I could do is make it more efficient here. So that's one shortcoming, but it's a good idea. And yes, they've been talking more and more. You hear about conferences, particularly scientific conferences, are trying to go hybrid, if not all virtual. And deforestation. So here's an interesting thing. I'm going to go back to greenhouse gas concentration. And I'm just going to take deforestation, which is happening too much. Even if I highly reduce deforestation, you can see that that actually didn't bring the temperature down much at all. Because while it does emit greenhouse gases, it is not what's called a high leverage solution. Yes, we need to stop it, but we need to stop it actually for many more reasons than greenhouse gases. We need to stop it to protect biodiversity and erosion and habitat loss, and as well as climate change and global warming. And what if we plant forests? Everyone's saying plant, 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 and you guys are master gardeners, so you must want that. Well, if I wanted to up my afforestation, you'll see that while that does save us 1/10 of a degree, and it does reduce some of the greenhouse gas emissions, it actually is also not a high leverage solution for several reasons. And I'm going to show that to you. First of all, if we were to take all the land available for afforestation and we were to start planting trees today, here we are in 2021, you guys, master gardeners, certainly know of others that afforestation, it takes many years for a tree to grow. So it kills me. The emerald ash borer has hit my neighborhood badly. And these beautiful 60-year-old ash trees, there's about 40 of them that have died in the last 3 years alone. But you can see that if we plant trees today, they're not going to have a big effect in absorbing as much carbon dioxide as we want. Until later in the century. So afforestation and deforestation in combination still isn't a great solution there. It's not the only one. Is there anything else? I want to be respectful of the time, so.
Let's see. No, I don't see anything else unless I'm missing something.
No, then I'm going to just bring up one other effect, if that's all right.
Mhm.
So one thing that we have overlooked in this discussion, and many people unfortunately overlook around the world, is our buildings and industry. And our buildings in particular here in New Jersey, we're older communities, zoning laws are always the minimum. And many times builders build to the minimum. That's why they have things like LEED Platinum and LEED certifications, which are architectural certifications that you are energy efficient. And what if we retrofit buildings? Many of them are homes as well as our commercial buildings around the planet, and check out how much energy we'll save. And just that alone can bring down, we can hit that 2 degrees of global warming by just creating energy efficiency. If you go on to the website, the Statue of Liberty, not the Statue of Liberty, the Empire State Building, several years ago underwent a major renovation, and they found 8 different systems in the Empire State Building, and they addressed them and made it much more energy efficient. They use 3/4 of the energy that they used to use to heat and make that place workable. And they've saved millions of dollars in their energy bills, and they love to show it. There used to even be a display before COVID about their sustainability methods. So buildings and industry, it offers a great new jobs, building retrofitting in terms of insulation, in terms of more efficient heating and cooling methods, etc. We certainly need that. And you can see that all this together, it took moving a whole bunch of sliders, and we're still only at 2 degrees. So it's going to take us as a community, us as a modern society, It's going to take many things that we need to do in order to create and to avoid global warming. And that's what this allows you to take time and play with. Before I close this out, are there any last questions, Ellen?
Let me take a peek.
I have a question
Yeah.
again.
Yep.
Is there a slider for political willingness?
No, unfortunately.
Actually,
But this was created and has been shown to legislators and political thinkers around the world. That is actually was one of the basics. I'm going to stop sharing this application. Actually, I'll share my scenario, copy scenario link. You can, this is one of the coolest things. You can share what you've done. If you guys cut and paste that into your browser, you will be able to recreate what you just saw here. And this simulator was invented and created and continues to be used with global decision makers. I am trying to find a way to use this with our New Jersey legislators, with town, green teams, and environmental commissions and councils, so that they can see first on a global basis what needs to be done, and then how do we implement, what can we implement locally, like community solar power and more infrastructures. We've seen in the Biden plans, as a matter of fact, we need more electric vehicle infrastructure. My husband bought an electric vehicle and we rigged our garage so he can charge it nicely. But it brought to our attention that what do you do if you live in an apartment building? And of course, here in New Jersey, we have Guttenberg, New Jersey. Did you know that's one of the 10 most densely populated cities in the world? Guttenberg, New Jersey. And what do people do in these houses? They need their landlords to install these things. And how many of them is that going to happen? Or we need to have the technology created. People are looking into if we can make charging stations work like service stations. So can we power up those electric cars as fast as we can gas up our SUVs now? Then we'll have a service station system back in order. And then there's hydrogen fuel, and hydrogen, if we create that in a green way, that's another possible mode of transportation energy. So there's a whole bunch of things being experimented with, which is really, really cool. We just need to bring it up to scale, and we need to do it quickly in order to avoid the worst of global warming, which we are seeing. Every time you hear in the news, there's another heat wave or another forest fire or another storm that's ravaged someplace. It's because of global warming, and that's due to anthropogenic causes. So I want to thank you very much for having me here today, and I would love to come back if you want or answer any more questions.
Susan, I
Well,
have,
thank you, Susan. And your talk today was just fascinating and at times depressing, but I'm very happy that you also ended on an optimistic note, and I found